Okay, welcome back to this next part of my Earth to Mars video. And in this part, we'll pick up where we left off, where we're closing in on Mars. We're just less than 24 hours away. So let me go ahead and unpause the simulation, and we'll turn the HUD back on. Now, what I want to do here is I decided I want to show a couple of different ways that you can approach Mars. So I'm gonna I quick save the file at this point, and that will let me come back exactly to this point that I'm at right now. So what I want to do is there are a couple of different ways. Well, there are several ways that you can approach Mars. And one of them is where you come into the atmosphere and you, depending on, and a lot of this depends on which vessel you're going to use. But if you're going to use, if you're using a vessel like what I'm using here, which is the XR2, it has a really good attitude hold, angle of attack, hold, autopilot. And what that lets me do is come into Mars at a very, let's call it a fairly steep pitch, and I can use the whole bottom of the vessel, the XR2, as a brake, essentially, for the atmosphere. So I'll have a lot of surface area hitting the atmosphere, and that will really slow me down. That's one way to do it, and I think that's actually my favorite, because I think it's the most effective and it's the safest, and I'll show you all that here in a minute. But another way you can do it, and I'm going to try to show this also, is where you can come in to the atmosphere inverted. And what that lets you do is to use the shape of the XR2 so that you can fly through the atmosphere, sort of like an airplane, but since you're flying upside down, the vessel wants to kind of pull itself down toward the ground, and that'll prevent you from going back out into space. So rather than explain it anymore, let me just jump right in and sort of try to show what I mean. So I need to get a little closer to Mars. Right now I'm not within the gravitational influence, because you can see this is still showing red. So let me skip ahead a little bit further. At least get to the point where this is in the green. Go out to 1000x, and there we have it. And obviously when we get into the green, the HUD automatically updates. It now says that we're in orbit around Mars, and that means I can use the prograde and retrograde autopilot. So I'm going to go to the prograde position here, and what I want to do, now that I'm in the prograde position, turn off the autopilot. In order to do the first maneuver that I'm going to do is the first one I talked about, where I'm going to come into Mars at a steep angle and use the whole bottom of the vessel as a brake. And I've found through several attempts that you can get away with just about any periapsis you want, all the way down to even 0 or even a negative number. But there is a sort of a sweet spot in there, and it depends on your ship's mass, it depends on the angle of attack you use, and it depends on the velocity that you're going to approach Mars at. But typically speaking, that sweet spot is right there around 31 kilometers, and that's really close to where I'm at right now. But I'm a little high, just a tad bit high.
Translation.
So I'm going to translate down to where I'm at about 31. Actually, that's pretty good right there. Just slightly over 31 kilometers. And as long as you're approaching Mars at a normal, velocity, then that will allow us to use the atmosphere completely as a brake and get captured and have a low apoapsis on the other side. So let me just go ahead and warp time ahead now, and you'll get to see what I mean. So currently we are at quite a ways out, so let's just warp time in. And at this point, obviously, I'm not worried about base alignment and all that, because I'm just gonna reset the scenario here in a moment anyway. Okay, so just kind of keeping an eye on the altitude here. Okay, we're getting down there to 500 kilometers. 300, let's go back to real time. And let me get into the prograde position again, just to get the vessel settled how I want. Okay. Turn that off. I'm going to get in a little closer yet. Okay, that's pretty close. Let's go ahead and turn the APU on. Close the radiator. And get the autopilot ready.
Rotation.
And again, the exact outcome of this will depend on many variables. Again, it depends on the velocity, depends on your ship's mass, depends on the angle of attack that you use. I stick with this angle of attack of 65 degrees for this particular maneuver. That's the one thing I typically don't ever change. If I need to, if I'm approaching Mars at a different velocity, I'll sometimes change the PEA that I'm going to use, maybe by, a half a kilometer or so. But I find that typically this works really well. So let's take a look at the external camera for a moment. And it's easy to understand why this works so well if you look at it sort of from this angle. This whole part of the vessel is going to be getting drag from the atmosphere. Whereas when I show you this other method where I'm going to do an inverted approach to Mars, the only part of the vessel that's getting drag from the atmosphere is basically the nose and a little bit of this part, so we're not going to slow down nearly as quickly. And the other thing about this, if you keep an eye on our heat, our temperature display, notice that we never get very hot at all. So not only is this approach very fast in terms of slowing us down, you'll see how incredibly fast we slow down, but it's also very safe. We just don't ever warm up very much. But if you keep an eye on the orbital speed, keep an eye over here sort of on the eccentricity as it quickly devolves, and I'll bounce back and forth between the internal and the external camera just so you can see what's happening. But notice how relatively quickly our orbital speed is coming down, and notice our eccentricity is just whittling down very rapidly. And our temperature is, we're very cool. Now we're getting some atmospheric drag, so we're really getting a lot of braking activity at this point. See that orbital speed just dropping very rapidly. Temperature, not a problem. And we're 13 seconds now away from
Mach 26.
periapsis. And we're almost captured. Eccentricity is almost
25.
below 1. Now we're captured. Temperature display.
Mach 24.
Velocity. See,
Mach 23.
we never even got, even close to being into the yellow or anything like that. So, relatively speaking, this is a very safe way to do a braking maneuver here.
Mach 22.
Orbital speed still coming down. Take a look at that external view again.
Mach 21.
And we're still fairly low in the atmosphere, so we're still getting quite a bit of orbit circularization for free. We're not using any fuel to do this. It's one of the great things about atmospheric braking. Our apoapsis is all the way down to about 2,000 kilometers and still going down. Ideally, if we can get that down to something like 500 kilometers or less, then that would be very good.
Mach 19.
Apoapsis is down to 1,400 kilometers. Orbital speed still coming down. Now we're climbing up through the atmosphere, which is fine, because for this particular maneuver here, this is actually what I want to do. Because remember, I never did line up with the base, so I want to get back into orbit. Apoapsis is down to 950 kilometers and going down. Temperature, of course, is not even an issue anymore because we're climbing back up through the atmosphere. Apoapsis down to about 700 kilometers. And once our altitude here gets up to 65 or so kilometers, then we're basically not going to be getting any more circularization. Getting close to 500 kilometers here. So you can see this was a very successful air braking, atmospheric braking maneuver. And for all the reasons I already mentioned, this is my favorite way to do it. I just feel it's the most effective and the safest way, and arguably the most realistic. Apoapsis down to 400 kilometers. And if I wanted to, I could turn off the autopilot now, and in fact, since my PEA is starting to drop, I think I'll go ahead and do that. I'm up to 55 kilometers in the atmosphere and just climbing slowly. And I'm at a pretty good altitude for orbital maneuvers. So let me go ahead and now go to the prograde position. And that should keep me from losing really any more altitude on the periapsis.
APU fuel 80%.
And we'll reopen. Yeah, we can go ahead and open the radiator now. As soon as the radiator is open, I'll turn off the APU. Turn off the Prograde. Okay, now I'm almost done with what I wanted to show here, but let's go ahead and finalize a couple things. Let me bring up an external MFD. Okay, so let's take a look at what we have. We have an apoapsis of 323 kilometers, and we're now climbing back up through the atmosphere a little bit. So what I'm going to do, is fast forward over here to apoapsis, and then circularize the orbit. And if you consider what that did for us, that got us into, into the Mars atmosphere. We used the atmosphere as a brake, so we didn't use any fuel to slow us down. And now we're going to circularize the orbit around Mars, so that we can then go on to do our base alignment and all of that. So let me go ahead and fast forward over here to apoapsis. As I'm coming up on apoapsis, let me go ahead and bring up burn time calculator. We'll just go ahead and make this process a little more scientific. Press MD for time to apoapsis, and then press the circular button. And then as I get right up to time to ignition, I'll press the Prograde autopilot to get in position. Getting close to that point. Go to Prograde. Go ahead and warp time ahead to the time to ignition. And with using just a little bit of fuel, there wasn't much of a burn at all, we now have a circular orbit around Mars. So I think you can see how beneficial that is to do that. Let me go ahead and quick save at this point. And now let me back out and show an alternate method for doing something similar.
All systems nominal.
Okay, so we're back at that point where we are out away from Mars. Let me bring the HUD back up. So this time I've got my joystick here in front of me, and I'm going to do the inverted entry into Mars this time, just to show, that there are a couple of different ways to do it. My PEA is at a good number right now. I'm not as concerned about having this at exactly, 31 or 30, 32, whatever, because of the fact that I'll be controlling the flight manually. It's not as important to have that at some specific point. So I'm going to go ahead and warp time ahead to get down to Mars. And here we are coming up to Mars in about 1,000 kilometers. Okay, we're getting in there pretty close. Now let's get ready. So I'm going to bring up the surface HUD.
Translation, rotation.
And I want to rotate over so that I'm, upside down. And I want to be level with the surface this way. Okay. Now let me get in a little closer. Okay, we're getting in pretty close, so let's turn the APU on and close the radiator.
Hitch on.
Turn surface controls on. And let me warp in a little further because I need to get some atmosphere impact. There we are. So now I can see that my vertical speed is negative 900 meters a second. Still need to get down a little lower into the atmosphere. Getting 70 kilometers. I'll be doing most of my steering below 30 most of my steering, I guess you could call it, when I'm down below 30 kilometers.
Off.
And if you watch the temperature display, you'll notice that we have a very different scenario here. And if you also watch the orbital speed, actually, in this case it'll be true airspeed, it'll be very different. We're going to be getting very hot, and we're not going to slow down nearly as quickly. And it's pretty easy to understand the physics of this. If we quickly take a look at the external view, and I got to do this quickly because I don't have a lot of time. If you consider how much surface area we now have hitting the atmosphere, it isn't nearly as much. So that's why this method isn't as it's not as fast. I don't know if I want to say it's not as effective. It's just not as fast. So I'm watching my vertical speed, and I want to make sure that my meters per second stays within a range that I can control. If it gets to, down to 500-600 meters a second negative, then I'm going to dip way down to the atmosphere so fast that I won't be able to control it. So I'm getting down to 32 kilometers, but I want to get even lower. Basically, I decide how low into the atmosphere I can get based on my temperature. And the slower I get here, the lower I'm able to go into the atmosphere. But I want to get as low as I can without burning up, just because the lower I am, the more drag I'll have. So let me go ahead and dip down a little further. Take a quick look at the external view so we can see what's going on. But you can see just the radical difference here. Our airspeed is not going going down nearly as fast, and that means that our eccentricity, which is how close we are to being captured by Mars, is not going down nearly as fast. So just this whole process would take a lot longer. But it's kind of fun if you got a joystick at least, because it feels more like flying. Keeping an eye on my temperature there, it's starting to warm up, so let me pitch this way a little bit to make sure my vertical speed gets closer to 0. And I'll just sort of fly through the atmosphere, right here around 23 kilometers for a while, until I slow down enough that I can dip down even further into the atmosphere. And I don't know if I'm going to actually complete this whole thing all the way through to, capture, just due to the fact that it takes so long. But I just wanted to show, the concept. As long as you keep your vertical speed down there, it's something you can control. I'm just very gently pitching the vessel up and down with my joystick. Just trying to stay right in there, around 23 kilometers for now. Because my temperature is even though it's high, it's not into the yellow. I'm not getting any hull warnings or anything like that. So I might as well be as low as I can so that I'll slow down faster. Looks like now we can get away with about 22 kilometers. Temperature's creeping up there a little bit, so let me pitch this way to get my vertical speed back to about 0. And maybe we'll hang out here around 22 kilometers for a bit. And the orbital speed, or true airspeed, whatever you want to call it, up there, you can see it's just barely creeping down. So this is a much more, drawn out approach. I think what I'll do at the very least, though, is I'll go ahead and do this up to the point that I get captured by Mars. and then I'll just say, well, you get the idea for that. So I'm slowing down a little bit. Now I'm down to 5,400 meters a second, so I can dip down into the atmosphere a little bit more. Get down around.
APU fuel 80%.
Get down close to 20 kilometers.
Mach 26.
Temperature's getting into the yellow there, so let me go ahead and pitch up a little bit so I don't get into the red. Right around 20 kilometers looks good. And we're cooling off again, so let's let our vertical speed go negative for a bit, and we'll dip down even lower, and that'll just slow us down faster. Keeping an eye on the temperature, it's creeping up there a bit, so let's pitch. Let's call it
Mach
up.
25.
Eccentricity's down to 1.19, so we're getting pretty close to the point of being captured. Go ahead and pitch up here. My temperature's starting to climb pretty well there. Be getting a hull warning here soon if I don't watch it. Down to 5,000 meters a second velocity. Okay, go ahead and let the vessel settle back into the atmosphere a little bit more. Take a quick peek at the external view while I'm doing that.
24.
If you zoom way in, you can actually see, kind of looks like the whole bottom here is in a lot of plasma. And there we're captured. So this is another way to utilize the atmosphere of the planet so that you can get captured without using any fuel at all. And obviously, if I just continue this process, I will continue to bring down the apoapsis. You can see right now it's at 50,000 kilometers and going down. And now I'm down to the point where I can hang out here around 16 kilometers in the atmosphere and not worry about overheating. Apoapsis is 27.
Mach 22.
Okay. I'm going to go ahead and end this video at that point because I think you get the idea. The temperature, the key to this type of atmospheric maneuver is just to keep an eye on the temperature and keep an eye on your vertical speed. Do not want to let your vertical speed get out of control so that you dip way down into the atmosphere, and you don't want to let it go the other direction because then you'll climb back out into space and potentially if you haven't been captured yet, then you'll fling off out into space and miss your opportunity to get to Mars altogether. But
Mach
at this point
21.
I'm already captured, so even if I flung out into space, it wouldn't be that big of a deal. I would just have to go around. But at any rate, that's the idea. So let me go ahead and pitch up here. Obviously, I wouldn't pitch up this early if I were doing this for real, because I would want to continue to bring my apoapsis down, but I'll just show you here how you can get back up out of the
Mach
atmosphere
20.
when it comes time. Just pitching up like that, and we're just climbing back out now. Got the apoapsis all the way down to 2,000 kilometers, 2,700 kilometers. And I'm still climbing up out of the atmosphere. And it's pretty good right there. We'll get a
Rotation.
rotation.
Wash.
Turn off surfing controls now. Now we can switch back to the orbit HUD. Go to Prograde. And now we're just back to business as usual. So, alright, you get the idea. I'll go ahead and end the video at this point, and we'll pick up in the next part.